And these graphs we already discussed. Okay. Now, this one was experimental study of Holwas and Leonard related to the characteristic of photoelectric effect. Repeating the observations from experiment. See, experiment was performed with the help of the radiation with different intensities and different frequencies. And the graphs were plotted for potential difference across emitter plate and collector plate and photoelectric current. First, by keeping frequency constant F1, 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 the intensity of the incident radiation was increased. Then they observed this thing. As intensity increases, the photoelectric current increases. But if the positive potential at the collector is increased, there is no effect of it on the photoelectric current, means photoelectric current remains constant one. But if on the collector negative potential is applied and if the negative potential is increased, then the current decreases, and for a particular negative potential at the collector, the photoelectric current becomes zero. That particular negative potential for which the photoelectric current becomes zero, that is called stopping potential. And see here, then after, by keeping intensity constant, when the frequency of the incident radiation was increased, then they observe this thing. If intensity is the constant, then the current obtained, that is the same one. Again, if the positive potential increased at the collector, the current is constant one. But when the negative potential is applied and is increased, no doubt current decreases, and finally at a particular value of the negative potential, current becomes zero, and that is the stopping potential. But here, as the frequency increases, the stopping potential also increases. Clear? And if the frequency is kept same one, the stopping potential remains the same one. If the intensity is increased, current increases. But see here, if the frequency is changed, there is no effect on the current of the frequency. So these type of observations were observed by these two scientists. Clear? So from these experimental observations, one can easily conclude this thing: photoelectric current directly proportional to the intensity of the light. And if we plot the graph of photoelectric current versus intensity of light, then it is a straight line graph. Similarly, if we increase the frequency of the incident radiation, then stopping potential also increases. Means stopping potential directly proportional to the frequency of incident radiation. So if we plot the graph of a stopping potential versus frequency, then that is also a straight line graph. Okay, but that particular graph intersect the frequency axis at a particular point, and that particular frequency at which this graph intersect the frequency axis, that is the threshold frequency. That is the threshold frequency. Okay.